How should we be framing the role that computers play in today's society? Should we see them as assistants, or should we conceive of them as tools? Both provide us support to accomplish tasks, but the similarities, they end there. On one hand, an assistant is a tool, is an entity with an independent existence from our own, and on the other, a tool is an object which we wield as an extension of self. An assistant offers capabilities that complement our own. However, when we utilize these, it often comes at the expense of surrendering some degree of control of the task at hand. Tools, rather than complement, augment. They expand our total capabilities by extending the self into the environment, where we can adopt the capabilities of nearby objects. The distinction between the two is best characterized by the difference between two words: delegation and empowerment. It's a subtle distinction. However, the implications of this run deep, informing the expectations and attitude we build around our technology and its use. A model example of the assistant paradigm is the recently released DALL-E 2. So DALL-E 2 is an AI system developed by OpenAI that's capable of independently generating detailed illustrations of a wide range of concepts in mere seconds, requiring just a simple text input. As a tool counterpart, we have Adobe Photoshop, computer software that's capable of taking our ability to visualize concepts and amplifying those. So you might already be picking up on the stark value contrast between these two systems. However, the contrasts don't quite end at values. They show themselves once again in the divergent North Stars held by both systems' architects. DALL-E 2 is merely an intermediary destination along a trajectory headed towards artificial general intelligence. Computer systems that have a capacity to have a cognitive capacity that far exceeds any of those of any person living or dead. Similarly, Adobe Photoshop could be seen as an intermediary destination along a trajectory headed towards brain-computer interfaces. A digital layer to the brain that creates a direct communication pathway between our minds and any device external to them. The paradigm which we choose and entrenches a value system that runs deep, informing the goals, incentives, and constraints, and the design of the technology that emerge from them. Which raises the question, which should we be selecting? Are we more interested in seizing control and responsibility, or rather, are we more interested in ceding control and responsibility? And if so, where exactly should we be drawing the line? See, though, the mistake is considering this as two completely different options, as opposed to two opposites along a continuum. And when we phrase the picture in this way, it's quite easy to wonder what exactly influences our placing along this continuum. Communication. It is the tight communication loop between machine and person, which is characteristic of the tool paradigm that creates this illusion of there being a single entity. Put another way, by reducing the overall time interval over which communication takes place, the overall uncertainty between tool and machine reaches a critical point where, after this, they share a shared common understanding and intent. And past this critical point, machine and person appear to be a single entity. Collaboration with a tight enough communication loop is indistinguishable from synchronization. The same phenomenon in the opposite direction is what gives rise to the AI alignment problem, where the machine and a person have a fairly loose communication loop. These matters were particularly relevant to me last year when I began work on a proof of concept user interface. It was apparent to me then, and still is currently, that computers in their modern form do not benefit us all equally. They, by and large, only support able-bodied people who perform knowledge work. Those with lasting visual or motor impairments have been effectively locked out of the information age. But they're not alone. When we think of permanent body impairments, we typically gravitate towards permanent body impairments, where we neglect to consider temporary body impairments, such as a broken arm, or situational body impairments, such as a driver's inaccessible hands or a bartender's impaired hearing in a loud environment. And to be frank, we've all been failed by the inaccessibility of today's modern computers. Just think back as recently as the start of the pandemic, when we all experienced screen fatigue or wrist illness every time we wanted to use touch to operate a shared computer. Our present is at odds with the future that motivated those from the past to kickstart this computer revolution, which is what motivated me to design a multimodal user interface that could support the on-demand substitution of voice input, motor input, visual output, and audio output, treating all of these communication channels as equally. However, when I set off to design this user interface, I experienced something rather surprising. Most leading practitioners in the voice user interface ecosystem have designed their systems around the assistant paradigm. And in the process, they've attempted to deliver on two promises: human-level communication and human-level intelligence. However, both come with their drawbacks. The motivation behind adopting natural language as an interface for communication is likely driven by the desire to reduce learning costs. However, doing this comes with the problem of rate limiting communication, the efficiency of communication, to that of natural language. And in the process, we effectively abandon any opportunity of increasing the rate of communication to hit the synchronized degree of communication that is characteristic of the tool paradigm. And when it comes to human-level intelligence, most of the systems have designed the capabilities in such a way that they have curated the capabilities around the limitations imposed by this promise, resulting in systems with narrow functionality, which pretty much defeat the whole purpose of general-purpose computing. So instead, I sought to design my system around the following system objectives. Many of them had been inspired by systems developed by many of the original people that had worked within the voice user interface ecosystem. Tool-rooted, context-free, ability flexible, mode flexible, and error tolerant. And I designed these around an application that is best characterized as a combination between a note-taking app and a voice note recorder, which could create audio-textual documents using pretty much just voice and audio output. However, they did support motor input and visual output. In order for voice input to match up or compete with motor input, it had to match it or exceed it in many of the places that mattered. This includes efficiency to be able to get those tight communication loops and precision to allow for robust general purpose computing. Fortunately, speaking is 3 times as fast as typing, and it also supports multiple dimensions where you can encode information, such as language content, pitch, speaking rate, and loudness, all of which can be used to encode information. And when it comes to audio output, one of the benefits of it is that you does not demand all of the user's attention, which is why you can listen to music while playing, cooking, driving, and working. However, one of its limitations is that it cannot match up with the efficiency of visual output. The average person speaks or reads at about 250 words per minute, whereas the average person typically speaks at about 135 words per minute, which serves as a rate restrictor for how quickly we can listen.
Make selection. Write. Copy. Paste. Paste. Play entry. This is a demonstration of a system that does not require the use of hands to capture one's thoughts.
So speech recognition played a pretty important role in the design of the system. And so in order to overcome some of its technical challenges, I had to intervene at multiple levels of the voice stack. However, most of my time was spent at the comprehension level, at the design of a structured yet flexible voice command grammar, which could take the intent of an individual and represent that in a way that could be easily understood by the computer, which was an approach to the problem that had not been favored by most people in industry. And the hope was, by creating this voice grammar, it would introduce the structure necessary to improve the speed and the precision of communication, to try to move the system in the direction of the tool extreme. A secret between you and me, though, the system did not perform as intended. It didn't match the efficiency of visual output or motor input, nor was the error handling quite elegant. However, it did show glimpses of the potential in a context-free, ability-flexible, and mode-flexible way of interacting with computers. However, right now, we're at a crossroad, and we should consider deeply whether we seek to cede control, responsibility, and action, or seize control, assume responsibility, and take action. Assistant or tool, extend or complement or extend, delegate or empower. Thank you.